Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from January 2024 paper 2. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 16 says a metal rod on top of a church may have been the world's first lightning conductor. The metal rod is connected to the ground by a steel cable as shown in the figure. So here we have metal rod, so this one is the metal rod, and then we have a steel cable, so this is the steel cable. So it's very important to see and read question carefully. So this one is the steel cable. So we can say this one is steel cable. When lightning strikes, charge is transferred to the metal rod and is conducted to the ground through the steel cable. For part A, the steel cable has a diameter of 12 millimeters. Total resistance of the cable is 0.078 ohms. Calculate the total length of the cable and resistivity of steel is given to us. In order to answer this kind of questions, it's very important first of all write down what is given to you. If you're struggling with physics, try to be more disciplined and systematic. So write down first of all what is given to you. For this question we have the resistance that is equal to 0.078 ohms. Then it is given to us resistivity that is equal to 1.4 times 10 to minus 7 ohms meter. Then diameter is given to us. We can simply say diameter that is 12 millimeters. 12 millimeters. As this is in ohms meter, so we can also convert this one into meters. So we can say this will be 12 times 10 to minus 3 meters. So we need to find out value of L. So for resistance you need to understand R is equal to rho L by A. We need to find out value of L, so we can rearrange this one. We can write down here L will be equal to RA divided by rho. Now simply you need to plug in values. Resistance is given to us that is equal to 0.078 and A is representing cross-sectional area, means this cross-sectional area R you can see this is cross-sectional area. How we can find this one? This is circle, so this is pi by 4 d square divided by resistivity. Resistivity we have that is equal to 1.4 times 10 to 7. Now we need to plug in simply values and we can find the answer. We need to plug in value of diameter, and if we simplify we will be able to find the final answer. So let's plug in values. First of all we have 0.078, then we have pi by 4, and diameter we have that is 12 times 10 to minus 3 square divided by the resistivity that is 1.4 times 10 to minus 7. Now if we simplify, in this case value of L we will get that is equal to 63.0 meters. So this is our final answer. This question is very straightforward one, just simple use of this equation, and you need to be careful with units. So this unit you have to convert into meters. Part B says during a lightning strike there was a potential difference of 1.5 times 10 to 8 volts between the metal rod and the ground. This PD caused a current of 1.2 times 10 to 4 amps in the cable for a time of 70 microseconds. Calculate the work done as the charge is conducted to the ground. So first of all we need to visualize this question. It is given to us the PD between this rod and the ground. If we connect a voltmeter here, so if we connect voltmeter here, the reading on this one is given to us that is equal to 1.5 times 10 to 8 volts. And current passing through this steel cable, current I is given to us that is equal to 1.2 times 10 to 4 amps. We can understand this one in a simpler way. Imagine that we have, this is the cable, so you can also imagine this is the wire, and current passing through wire is given to us that is equal to 1.2 times 10 to 4 amps. And if we connect a voltmeter across this wire, PD across this wire is given. So here we have our voltmeter. PD across wire is given to us, that is equal to 1.5 times 10 to 8 volts. We need to calculate, in this case, work done, and work done is equal to the energy transfer, electrical energy transfer, and electrical energy transfer will be equal to Q times delta V, and Q, we understand Q is equal to I times T. So we can simply rewrite this one. So here we have I times T times delta V. Now simply we need to plug in values, nothing else. So we have value of current here, that is equal to 1.2 times 10 to 4 amps, and we have value of time, that is 70 microseconds. So you need to be careful with units. So this is 10 to minus 6 seconds, and we have value of V, that is 1.5 times 10 to 8 volts. And now if we multiply them, we will get 1.26 times 10 to 8 joules. So this is the work done to pass charge through the steel cable. So this much work has to be done. So this is our final answer. Part C says the steel cable is replaced with a copper cable. The copper cable has the same length and diameter as the steel cable. During a thunderstorm, the PD between the metal rod and the ground is the same for the copper cable as it was for the steel cable. Copper has a lower resistivity than steel. There is a greater number of conduction electrons per unit volume in copper than in steel. A student states that the drift velocities of electrons will be the same in both cables. Assess the student's statement. So for this question, first of all, we need to understand resistance is equal to rho L divided by A. In this case, A is the same, L is the same for two cables, then resistivity of copper cable is lower. It means its resistance is lower. So this is first point we need to understand. Copper has lower resistance. Then the second thing we need to understand, as PD is the same, so we can say PD is equal to I times R. If PD for two cables is the same, and if resistance decrease, it means current has to increase. So these are two basic points we need to understand. Now current, we have to relate this current with drift velocity. So we can write down I, this is equal to NQVA. So this is the drift velocity. As in this case, current increases, but A is the same, and it is given to us. N also increases. If current and N increase by the same amount, then we can say that V will stay same. But if they increase by different amounts, then V will not be the same. Q also, you need to understand, this is the charge on single charge carrier, so this is also constant. So student might be correct. So these 3 points we need to write down to answer this question, and this question has 3 marks. So this is how systematically you can approach the problem. So what is given to you and what you can get from that, then you need to connect with the next concept, then with the next concept. So this is how we approach problems in physics. Now let me show you the answer, how you can write down your answer. In the answer, you can talk about this point. You can say the copper cable has a lower resistance because length is the same, diameter is the same, and it has lower resistivity, so resistance will be lower, as we discuss here. If same PD across two cables, there will be higher current, as we have discussed here. Since I is equal to NQVA, student might be correct. So if you write down these 3 points, you will get 3. Question 17 says boats can shelter from waves on the sea in a harbor. The diagram shows a harbor where boats can enter and leave through 2 gaps in the harbor wall. So we have gap 1 here and we have another gap here. Waves on the sea are diffracted as they pass through the gaps in the harbor wall. Means when they pass through this gap, the waves, they diffract like this. So they pass through this one and waves will diffract. For part A, we need to describe how Huygens construction principle can be used to predict the shape of diffracted wave fronts. How we can determine the shape of these diffracted waves. For this one, simply we need to understand Huygens principle, and this is what you need to write down for the answer as well. Huygens principle simply tells us each point on a wavefront is treated as a source of secondary wavelets. These further wavelets, they interfere and the resulting waves predict the shape of diffracted waves. Let's try to understand this one with the help of this diagram so you can have better understanding. This principle simply tells us, so this one is the wavefront, so each point on this wavefront is a source of secondary wavelets. So these are the points. So each point is a source of secondary wavelet. So you can see these secondary wavelets. And when they interfere with each other, so they will determine the shape of resultant wave. If we combine these peaks, so if we connect them, so in this case it has to be a straight line. Same principle is true here as well. So you can see we have this is our first wave, and each point on this wave is a source of secondary wavelet. It will produce secondary wavelets. So these are secondary wavelets. So we have point here, so this is source of secondary wavelet, so this is the wavelet here. Now if we combine these points, so you can see here, if we combine these points together, we will get this circular wave, and this is Huygens principle. So in the answer you need to say each point on a wavefront, this is representing, this is wavefront, so this is wave front, and this is also wavefront. So this is wavefront, so this is also wavefront. So each point on this wavefront is a source of secondary wavelets, and when those secondary wavelets they interfere, we can determine the shape of resultant wave. So this is Huygens principle. Let's try to understand Huygens principle in a better way. Now let me explain you this one with the help of animation. Watch this animation carefully and try to recall Huygens principle and try to apply on this animation so you can have better understanding of principle. So in this case you can see the secondary wavelets, you can see the original wave, and you can see the resultant wave. And also you can see if we increase the number of gaps or we decrease number of gaps, how resultant wave will change. I hope now you have better understanding of Huygens principle. If you still have any questions, you can leave questions in comments. If you want to watch this once again, so you can watch this one once again. So you need to focus on original wave, secondary wavelets, and resultant wave, and how resultant wave is depending on number of gaps. Part B says the wavefronts in the sea arrive parallel to the harbor wall. The wavelength of the wave varies as the weather varies. There are identical boats at positions A and B in the harbor as shown in the figure. As the wavelength of the waves varies, the boat at position A always very important one, always oscillates with a large amplitude. The boat at position B sometimes oscillates with a large amplitude and sometimes oscillates with a very small amplitude. So first of all we need to understand why boats will oscillate. Boats will oscillate due to the waves, because waves will cause water to oscillate and water will cause boats to oscillate. So this is one thing we need to understand. As this boat always oscillates with large amplitude, it means that when the waves reach at this point from two gaps, they are always in phase. We can say the waves are always in phase. So here is constructive interference. So wave interfere constructively. So we can say constructive interference at position A all the time. Now we need to understand why there is constructive interference. If we look at the distance traveled by the waves to reach this point from gap 1 and from gap 2, this distance travel is the same. So the path difference is equal to 0. So it means waves are always in phase. So this is first thing we need to understand. Now if you look at position B, here we have sometimes we have constructive interference. So we can say sometimes we will have constructive interference, or sometimes there will be destructive interference. So listen carefully, very important point. This question is very important about interference and diffraction. So constructive or destructive, it means that sometimes waves, they arrive this position in phase, or sometimes anti-phase, means out of phase. The better way to say is out of phase. So sometimes they are in phase, sometimes they are out of phase. So here, now we need to understand when they will arrive here in phase and when they will arrive there out of phase. So this is the distance traveled by the waves. So one wave is coming from here, so at this point, and the phase difference is depending on the wavelength. So due to the change in wavelength, waves at this point, they can be in phase or they can be out of phase, because the phase difference is depending on wavelength of the waves. So these are the points we need to understand to answer this question. If these points are clear to you, now we can write down the answer. Now let me show you the answer, how you can write down. So this is how you can write down the answer. In the answer, you can talk about waves from each gap superposed at positions of boards. At position A, there is no phase difference, means waves are always in phase, so there is always constructive interference. So there is large amplitude oscillation. If the waves are in phase at positions of the board, there is constructive interference, and due to constructive interference, amplitude will be larger. At position P, the phase difference varies with wavelength. If there is odd number of wavelength, half wavelength, path difference, there is destructive interference. Mean if the path difference is equal to the odd number of wavelengths, there will be destructive interference. If path difference is equal to odd number of wavelengths, it means that if PD, this is equal to odd number, so here we can say odd number of half wavelength. So here we have lambda by 2. If n is equal to 1, n is equal to 3, n is equal to 5, 7, and so on. So at this point, we will have destructive interference, because if n is equal to 1, so what is the path difference here? That is equal to lambda by 2. So the phase difference will be equal to 180. And if n is equal to 3, so it means this is 3 lambda by 2, again one cycle and half cycle. So when waves, they reach at this point, they will be out of phase, so there will be destructive interference. So if destructive interference, it means amplitude will be small. So these are the points we need to understand to answer the question. And second, we can also say that if path difference, this is equal to n times of lambdas, n can be equal to 0, n can be equal to 1, n can be equal to 2, 3, and so on. Then at this point, waves will be in phase, so there will be constructive interference, amplitude will be large. So these are the points you need to understand. These points are very important. We have discussed these points in detail because this question is very important to understand. You will see this type of questions in many past papers. So if these points are clear to you, next time when you see the question about interference, constructive interference, destructive interference, you will be able to explain based on phase difference, you will be able to explain based on path difference. And you will be able to explain when amplitude will be greater, when amplitude will be smaller, and so on. Question 18 says the resistance of a particular thermistor varies with temperature as shown in the figure. A student connected the thermistor in series with a battery and a resistor as shown in the figure. The resistor was made from a long length of wire. At a temperature of 45 degrees Celsius, the resistance of the thermistor was 4 times the resistance of the resistor. The power P dissipated in the resistor was 0.38 watts. For part A1, derive the equation P is equal to V square by R. So we can simply start with P is equal to VI. P is equal to VI, but we don't need I, and from Ohm's law we understand V is equal to I times R. So from here we can say I will be equal to V divided by R. So we can plug in this value here now. So we can say V and I is equal to V divided by R. Then if we simplify, we will get V squared divided by R. So this is what we need to derive. So if you have written these two steps, you will get 2 marks for this question. For the second part, we need to determine the potential difference across the battery. Mean what is the value of V across the battery? So we need to find out value of V. So how we can determine? For this question, it is given to us at 45 degrees Celsius, resistance of thermistor is equal to 4 times of resistance of resistor. So if it has resistance capital R, so the resistance of this one we can say RTH. This is given to us in the question. Now simply if we look at 45 degrees Celsius, we can find out the resistance of thermistor, and resistance of thermistor in this case is equal to 35 ohms. So we can say this is equal to 35 ohms. So from here we can find out value of resistance of this fixed resistor. So we can say this is 35 divided by 4. So if we solve this one, we will get 8.75 ohms. So we have value of resistance. Now we need to find out potential difference across this one. So we can write down here, let's say potential difference across this one is V1. So we can simply say this is V1. And let's say the potential difference across thermistor, that is V2. Now we need to understand the relationship between V1 and V2. As in this case, current is the same. So if resistance of thermistor is 4 times, it also means that V2 has to be equal to 4 times of V1. 4 times of V1. And battery means the V has to be equal to 4 times of V1 plus V1. It means that it has to be equal to 5 times of V1. 5 times of PD across fixed resistor. So these are the basic concepts we need. So now if we can find out value of V, we can find out value of PD across this battery. For this question, it is also given to us the power dissipated in resistor, that is equal to 0.38 watts. So we can simply say 0.38 watts. This one will be equal to V square divided by R, and we have value of R, so we can say V in this case V square, this has to be equal to 0.38 times the value of resistance, that is equal to 8.75. So we need value of V, so simply we have to take square root on both sides. So we can say 8.75. If we take square root of this value, we will get 1.82 volts. So what is value of V then? So V simply will be equal to 5 times of 1.82. This is V1. So this is PD across resistor. So if we multiply this one, we will get 9.1 volts. So this is the final answer. This question has few steps. The first step is you need to understand this point, and this is given in the question. So if you have got this point, then simply you can determine the value of R. So if we have value of R, we can find out value of V1 because we have the value of power. This is given to us in the question, so we can find value of V1. And if we have value of V1, we can understand the relationship between V1, V2 and V. So in this case, V is equal to this. You can also say this is equal to V2 plus V1, but V1 is equal to 4 times, V2 is equal to 4 times of V1. So we have written this is 5 times of V1. So this is our final answer. Step by step. Sequence is very important. What is given to you for physics, you have to look at that one, and then Also they will ask you something to calculate, so you also need to keep an eye on that. So what you have, how you can use this one so you can reach the final answer. So that sequence between given data and the final answer you need to develop, and that can be developed with practice. So when do question, try to develop that sequence of the steps. So it takes time, it just matter of practice. So when practice, not just I have look at the mark scheme, I just copy everything. No, you need to understand how you will proceed from given data to the final answer. So if you do this practice with time, you will be quite good to answer this type of problems. Part B1 says, explain why the resistance of a thermistor decreases as the temperature increases. So we need to understand thermistor is made of semiconductor material. So it is made of semiconductor. Semiconductor means that fewer conduction electrons. So we can say fewer conduction electrons. Conduction also means that free electrons. So simply we can say fewer free electrons. As there are fewer free electrons, so thermistor is not a good conductor at low temperature. That if we increase temperature of thermistor, it means there will be more free electrons, so the resistance of thermistor will go down. We can also understand this one with the help of I is equal to NQVA. So if the value of N increase, so it means value of I will also increase. So if current increase, it means resistance decrease for the same PD. So these are the points we need to answer this question. This question has just 2 marks. Now let me show you the answer, how you can write down the answer. In your answer, you can talk about these points. You can say number of conduction electrons per unit volume increase. That is N, means the number density. N is the number density, number of conduction electrons per unit volume. So this increases. So current increases for the same PD because R is equal to V divided by I. So if I increase, it means resistance decreases. Second part says the student increased the temperature of both the wire resistor and thermistor from 80 degrees Celsius to 90 degrees Celsius. Explain why the current in the circuit decreased. So to answer this question, simply we can look at transport equation, means I is equal to NQVA. N is the number density. Number density means the number of free electrons per unit volume. So we can write it here. This is the number density. When temperature increase, so we can also write on here as temperature increase, number density increase means there will be more free electrons. So we can say number density increase. If number density increase, it means current will increase. But we also need to understand that V, the drift velocity, it depends on lattice vibrations. So we can write on here lattice vibrations. Lattice vibrations simply means that ions, they oscillate. So when we increase temperature, they oscillate faster. Before they were oscillating like this, then they start oscillating like this faster. So they occupy more space. So it makes very difficult for electrons to pass through that. So it means that drift velocity of electrons due to increase in lattice vibrations, if this one increase, it means drift velocity will decrease. So in this case, as current decrease, it means the decrease in drift velocity is more than increase in number of free electrons. So overall current decrease, so overall resistance of the circuit increases. So lattice vibrations increase with temperature. So this point we can also write down. So if you have understanding of these points, now we can write down the answer. Let me show you the answer, how you can answer this question. This question has 5 marks. So these points we can mention. So you can look at these points. First we have said increased temperature caused increased lattice vibrations in thermistor and wire resistor. So we have mentioned this point here. As temperature increase, lattice vibrations increase. This caused an increase in collision between electrons and the lattice in the thermistor and the wire resistor. Means when lattice vibrations increase, we can also write down here number of collisions between electrons and ions also go up. Number of collisions go up. Number of collisions increases. As number of collisions increase, it means drift velocity will go down. So the resistance of the wire increased because current decreases. So the total resistance of the circuit must increase. So the increase in resistance of the wire resistor must be greater than the decrease in the resistance of the thermistor. So when we increase temperature of thermistor, N increase. So here we are talking about overall value of N, means the net effect we are talking. Everything you are putting together, the net increase in number density of thermistor and resistor, and here we are talking about overall drift velocity. So that's the reason we have used this one. Question 19 says solar cells are made from semiconductor materials. One type of solar cell has two layers of semiconducting material, layer 1 and layer 2. Photons of light are incident on the solar cell as shown in the figure. The minimum energy to release an electron from a semiconductor layer is the work function. The work function of layer 1 is 1.86 electron volts. Calculate the minimum frequency of light needed to release an electron from layer 1. So for this question, first thing we need to understand that work function, this is equal to H times F, mean Planck's constant times frequency of electromagnetic radiation. We need to find out minimum frequency of EM radiation. So simply this will be equal to work function divided by Planck's constant. For this question, we have value of work function. So this is equal to 1.86 electron volts. We need to convert this one into joules and we need to get rid of electron volt. So this is 1 electron volt, and 1 electron volt we need to understand this is equal to 1.6 times 10 to minus 19 joules. So we can write on here 1.6 times 10 to minus 19 joules. This is how we convert units, divided by the Planck's constant. Planck's constant is 6.63 times 10 to minus 34 joules second. So this electron volt will be cancelled with this electron volt. So this is in joules now. And if we simplify this one, we will get 4.49 times 10 to 14 hertz. So this is the minimum frequency we need. And this frequency also we call is threshold frequency. So this one is also threshold frequency. So next time they can ask you to calculate threshold frequency if the work function is given to you. So this is also threshold frequency. So the answer for this question is 4.49 times 10 to 14 hertz. Part B says light from the sun is incident on the solar cell. The intensity of the incident light is constant. Layer 1 has a greater work function than layer 2. Photons not absorbed by layer 1 are transmitted to layer 2. Layer 1 is removed from the solar cell so that all photons now reach layer 2. Explain how removing layer 1 affects the rate at which electrons are released in the solar cell. You should assume that each layer absorbs all photons with a frequency greater than the minimum frequency for that layer. So first thing we need to understand, for this question it is given to us intensity of incident light is the same. So it means same number of photons. So we can say it means same number of photons are reaching the solar cell all the time. Same number of photons. So this is very important point. Now in this case we have two different scenarios. So we can sketch the first one. We have layer 1. So we can draw here. So this is layer 1 and threshold frequency of this one, let's say, is F1. Then we have layer 2. We can simply draw below this one. So we can say threshold frequency of this one is F2 and F1 is greater than F2. Now we can imagine, let's say, just 5 photons of light. So we have 5 photons of light. Let's say they are incident on layer 1 and only 2 of them, they have frequency higher than F1. Only 2 of them. So those 2 they will be absorbed. So two of them, they have frequency higher than f1, so those two photons, they will be absorbed. So let's say this photon has frequency greater than f1, and this photon also has frequency greater than f1, and these two photons, next two photons are simply next two photon, let's say they have frequency that is lower than f2. This photon also has frequency that is lower than f2, and this photon, it has frequency, so listen carefully, it has frequency that is greater than f2. So in this case, let's redraw this one for better understanding. Let's redraw this situation again. So what is happening in this case? So we can redraw this scenario again when we have two layers. So it means that in this case, from this surface, two photoelectrons will be emitted. So two photoelectrons will be emitted. And from this surface, only one photoelectron will be emitted, and remaining two photons, they will just pass through this one. So they will not be absorbed. So only three electrons are emitted. Now we can simply replace with one layer only, and we have same photons. So these photons, they have different frequencies because solar light consists of different colors, so they have different photons with different frequencies. So again we have these five coming. So you can see here we have five photons. One has frequency f that is greater than f1, and the second photon, this has frequency that is greater than f1, and the next photon, this has frequency that is lower than f2, and we have another photon that has frequency lower than f2, and we have one photon, let me draw here, this photon is here, it has frequency greater than f2. So in this case, now we need to count how many photons they have frequency greater than f2. So this photon has frequency greater than f2, this photon has frequency greater than f2 because f1 is greater than f2, so this is the point, and this photon also has frequency greater than f2. So it means these three, they will cause emission of photoelectrons from the surface. So how many photoelectrons will be emitted from this second layer? There will be three photoelectrons. So we can say three photoelectrons will be emitted, and these two photons, they will just pass through this one. So they will not cause emission of photoelectrons. I hope this makes sense to you. So in this case, it means that rate of emission is the same. How many electrons emitted from here? 3 electrons. How many electrons emitted from this surface? Also 3. It means rate of emission is the same. So rate of emission is same. Rate of emission is same. I hope this question makes sense to you. I try to explain you in a way so it makes sense. If this question is making sense and these videos are helping you, please like and subscribe because your encouragement is very important. More likes, more encouragement, more videos. So please like and subscribe and also share with your friends. And if you're looking for extra resources, join Patreon Edexcel IAL Physics. You will see a lot of resources there. Now let me show you the answer, how we can write down the answer. This is how we can write down the answer, and let me clean this part so you can see what I have written. So I will just clear this part so you can see how you need to write down your answer. In your answer, you can talk about these points. You can say the number of photons arriving each second on the cell is the same, so number of photons are the same because intensity is the same. Layer 1 absorb photons with a greater frequency of those emitted by the sun. Photons reaching layer 2 have frequency greater than threshold frequency of layer 2. One photon only interacts with one electron, so the rate of emission of photoelectron remains the same. So this is how we can answer. Main thing is the understanding of physics. Always try to understand physics, not just try to memorize. Physics is a technical subject, science subject. It needs your understanding. You need to develop something. It's not something you can just eat. You need to digest. So that become part of your blood, part of your way of thinking. Part C says a student connected two solar cells in series with a 4 ohm resistor as shown in the figure. The student adjusted the light condition so that each cell had an EMF of 5.0 volts and internal resistance of 0.80 ohms. The power dissipated in the resistor was 13 watts. The student suggested that connecting cells in parallel would cause the power dissipated in the resistor to be less than half this value. Deduce whether the student's suggestion is correct. A little bit long question and also a little bit tricky one. First of all, we need to understand each cell has EMF of 5.0 volts and internal resistance is 0.80. So we can write down here EMF of this cell is 5.0 volts and internal resistance of this one is 0.80 ohms, and same is true for this cell. So systematically you have to approach, and internal resistance of this one is 0.80 ohms. Now we connect these cells in parallel. So simply you can imagine this is one cell, it has internal resistance, and the other cell is connected here, it also has internal resistance. So here, and these two cells, they are connected in parallel. So this means they are connected in parallel. These cells are connected in parallel, and we have 4 ohm resistor that is connected here. So this one is 4 ohms resistor. We can also draw the circle around this one because this is solar cell. So we can draw this circle around this. So this is representing solar cell. Each solar cell has EMF of 5 volts and internal resistance is 0.80. So this small resistor is representing internal resistance. Now let's say current passing through this resistor is I. So how much current is coming from here? As these two are identical cells, so current from each cell will be half of the current passing through this resistor. So we can say this is I by 2. Now what is the net EMF? Net EMF in this case, this is equal to only 5.0 volts. Net EMF in this case, this is the net EMF. So the EMF of one cell is the net EMF because PD across this one. So if we connect voltmeter here, so the PD across this one, so you see it is connected across one cell. So the net EMF in this case is 5.0 volts. So what is the net resistance? So means net resistance of these two. Net resistance, or we can say the total resistance of these two cells. So we can say R total internal resistance. They are connected in parallel, so it means the total internal resistance will be half. So this has to be equal to 0.40 ohms. So in this case we can also say total resistance or total in the circuit. So this circuit, actually the better way is we can redraw this circuit. We can redraw. So we have one cell, so this is one cell, it has internal resistance and it has EMF of this one is 5.0 volts because the net EMF, because this is connected across this one and also across this one, so the net EMF across this one is 5 volts. Then what is the internal resistance? So that is 0.40. So we can replace these two cells with this one cell with this internal resistance and this value of EMF. So here we have resistor of resistance 4 ohms. Resistance of this one is 4.0 ohms. So what is the total resistance of the circuit? That has to be equal to 4 plus 0.4. It means total resistance is 4.4 ohms. So from here we can find out value of current will be equal to 5.0, means this EMF divided by total resistance in the circuit, that is 4.4 ohms. So in this case value of current we will get that is 1.14 amps. So how about the power dissipated in this resistor now? Power dissipated in the resistor, we can say that will be equal to I square times R. So we have I, that is equal to 1.14 square time the resistance of this resistor. We are talking about power dissipated in this resistor, and resistance of this one is 4. If we solve this one, we will get 5.19 watts. So this is the value of P power dissipated. At this new value of P, so we can say P new, that is equal to 5.19 watts. And what is the initial value of P naught? That is 13 watts. And this is less than half of this value. It means student suggestion is correct. So we can say student suggestion is correct. So this is how we can answer. The main concept is you need to understand when the cells are connected in parallel, what is the net EMF? Net EMF is equal to the EMF of one cell, because across this resistor we have each cell connected. So what is the net EMF in the circuit? 5 volts. And what is the total internal resistance as they are connected in parallel? So resistance will be divided by 2 because they are identical. Resistance divided by number of resistor. You can also use 1 by R formula. You can calculate, your result will be the same. What is the total resistance? So we can replace this one with equivalent circuit. So EMF is 5.0. What is net internal resistance? Means the total internal resistance, that is 0.40. Now simply we have to solve this circuit. So this is how we can answer questions when cells are connected in parallel. I hope this makes sense to you. If you still have any questions, please leave your questions in comments and I will try to answer as soon as possible. If this video was helpful and other videos on the channel, if they are helping you to improve your understanding of physics, please like and subscribe because your encouragement is very important. And if you are looking for more resources and extra help, join Patreon.